Hey, and welcome back for another episode of Show of Your CI/CD Pipeline. And today I'm here with Gunnar. Gunnar, great to have you.
Thanks for having me, Johannes.
What are we going to look at today?
Today, we're going to look at how you can use chaos engineering as a way to verify how reliable and how resilient your system is.
This sounds awesome, and I've not had that on my channel before, so really glad to have you here today. Maybe let's tell a little bit about yourself. So who are you? What do you do? How did we actually meet?
Yes, so my name is Gunnar. I am a developer advocate at AWS based in Sweden. I cover the north of Europe mainly, but throughout my time at AWS and many years before, I've had a lot of focus on resilience, on architecture, and so on. So I focus a lot on those kind of topics to perhaps inspire and help builders in different ways that they can make whatever they're building more resilient to failure, so that their customers or end users may have the best possible time, perhaps.
Yeah, that's a great way of saying you want to inspire builders to do things different, and that's exactly what also we're trying to achieve on this channel, right? Is getting people to think different about the way that they automate their way to production, right? So, before we go into the technical details, Gunnar, how did we meet? Do you remember?
I think our first contact was after, I think I did a session on how to build SaaS, multi-tenant SaaS on AWS at one of the online events we did. And I think you reached out after that session on LinkedIn. And from there, we started chatting more and more. And then you joined the Community Builders program, which just, I guess it helped us have even more contact. And now, well, you're an AWS hero, so we are even more frequent in touch, I'd say.
Yeah, that's great, right? So I also remember that Game Day World Championship thing, which you ran last year, which was a fantastic event. And at the moment you also run a SaaS on AWS show, right? Just I think last week you had a very good friend of mine on the show ran, and that was an amazing session as well. So much around introduction. I would propose let's jump into chaos engineering within your CI/CD pipeline. Chaos engineering, what is that from your perspective?
So I think we need to take a step back first and talk about just shortly about what resilience is. And when we're talking about resilience, we're talking about the way your system should be able to withstand different types of things that might happen to it. And it might be that things stop working in different ways, but you want to make sure that your application, or basically your end users, that they are still enjoying the time using your app or your system, whatever it is you're delivering to them. So we use different types of methods to make sure that our system is resilient to failure and that it is reliable. And we often talk about when we're talking about resilience in the cloud, we're talking about this continuous resilience, different ways that we can improve our application so that it is, basically more and more resilient to failure. We use different types of ways to use patterns, for instance, to anticipate different types of failures. We use monitoring as a way to keep an eye on our application, that it's working and that we are alerted if anything goes wrong. Then we try to respond to whatever happens. If something fails, we get that alert. Well, we want to respond to it and make sure that the application then gets back to the steady state, that it works as normally again. And then I think the most important part is we then want to learn from it. So if we had an incident of some sort, we go back, we look at what happened. How can we improve? How can we learn from it? Not only in a technical way, but as an organization. How can we as operators or builders or developers improve the way we're building an application? And that's the continuous cycle of resilience that we often talk about. And part of that learning phase, that is that practice of chaos engineering. So chaos engineering, it is the practice of injecting
I'm gonna
faults.
just inject for a second.
Oh yes.
The way that I always try to explain resilience is communications channels to your relatives or to your wife. Usually, you don't have only Slack or only Telegram or only Signal or only email. You always have like multiple channels, so you have a backup if something is that you want to really communicate to your spouse. And that's how I kind of explain resiliency a lot of the times, right? Where really it's the way of making sure that everything that you build is always available, right? You are prepared for failure, and you are prepared to have a backup if you need to do something. It's like picking up kids needs to always have two options. If someone cannot do it, right, the second one needs to do it. And that's how I try to explain it for myself.
Yeah, I think definitely, and that's perhaps the high availability part of it, to have that second person you can go pick up the kids if needed. In our world, well, maybe that's using multiple availability zones instead, which would be the equivalent to it.
Yeah, and but that also means that building applications need to have that in mind. Like, so we need to kind of architect for that already. And I think that's what a lot of people do not think about yet in organizations, right?
I think that's something we're seeing more and more, because we've gone into this world of the always on world. Things should work all the time. I'm expecting the app to be quick to respond no matter when I'm using it. I'm expecting every system to be online. If you see a website that says that it's down for maintenance these days, that's almost upsetting, because you want things to always be on. And that's why I think that anticipate part of the continuous resilience is so important, to think ahead of time, because things are going to fail. That's the famous Werner Vogel's quote, that everything fails all the time, because it does. Things are going to fail. So it's a matter about thinking about that ahead of time. What could actually fail in my application or my system?
And this is where chaos engineering comes into play, right?
It is. And because chaos engineering, it is a process that's been around and with different names throughout quite a few years now. But chaos engineering, it is the process of stressing an application by creating disruptive events, creating these faults, and then observing how the system responds to these faults, and then implementing improvements. And this is a way of then learning from an incident without actually having that incident. We can more proactively create these faults in our system. And we do it not to break the system, but instead it's to prove or perhaps disprove our assumptions about the system and how resilient it is to failure. So, for instance, we think about, let's say we're using an autoscaling group. Well, we expect that if one EC2 instance is terminated, that my autoscaling group will then detect it and spin up a new EC2 instance. And that's something we're assuming about our system. But we don't actually know it until we test that out, until an instance is terminated. And that's where chaos engineering comes in. We can then do these experiments. And that's the most basic of experiments, perhaps, terminating an EC2 instance.
Okay, that sounds like something that is really going to help us to not get into stressful situations, right? So we should really try to get that as part of our pipeline, is what I'm hearing.
Oh, yes. So what we perhaps, everyone who's built and then operated a system, they know that the things they happen at 3 a.m., it happens during the weekend or during holidays. But using something like chaos engineering, that helps us to, first off, be able to do these things during working hours when we have people in place that are able to quickly respond if something breaks. And then we do this manually. We create these experiments. But with the theme of this show, yes, the next phase of it is to automate it. So we're able to do this over and over again, and perhaps on every code deploy, by implementing it into our CI/CD pipelines. And that is exactly what we're going to look at in a bit.
So you want to do this on every code commit or on every deployment of your application?
Well, that is a question that I think I have to go back to that traditional solutions architect answer and say it depends. I think it depends on your application, your system, how quickly you need to get new code into production and so on. So I don't think there is one answer to it. I really think it depends, and it could probably look different based on different services within your system as well. Looking at it from an AWS or Amazon perspective, the way that we're using it internally, well, it's up to each team. We're famous for these two pizza teams that they build it and they run it, they own it basically. So they decide how they want to do certain things, and chaos engineering is one of those things that could differ based on the team, based on the service that they're delivering.
And yeah, and I agree. And I think that it also depends on the way that you build your CI/CD pipeline or your pipeline as a whole, right? So are you following the continuous deployment approach? Yes or no? Are you deploying on demand? And I think this really comes down to the project where you are. But I personally think that if you do have a continuous deployment strategy where every commit goes to production as soon as possible, right?
Yeah.
Then it is wise to include something like chaos engineering within that pipeline.
Yes. Yeah, and we'll see a practical example in a bit, but you of course have to think about how long you want to run your experiments before you then push something into production and so on. So there are things to consider when it comes to these, and what type of experiments you want to run on, if you want to do it on each deploy, for instance.
Yeah, I'm curious to learn more about that. So let's directly jump into it and let's look at what you prepared for today.
All right. So
that's bad. That's bad. Give me 1 second. I'm just fixing something. You are sharing your screen and I am not seeing it. So something I did wrong on my side, but I'm gonna get it working. Okay, so cool. Now ready to go. Let's go.
all right. So
Why not
we're
the
in the
pipeline?
AWS.
That's bad. I wanted to see pipelines only, Gunnar. You're not following the rules. Tell me.
I know. It's the chaos part of chaos engineering. So I'm just injecting faults into your show here. No, I want to start off with just showing chaos engineering in practice first before we then implement that into our pipeline.
So are we going to play a game day then?
Not a full game day. We're just going to do one single experiment in this case. And there are multiple ways of doing chaos engineering. The way we're going to look at it is, of course, through the AWS service, AWS Fault Injection Simulator, or FIS. So we're going to jump to FIS straight away. So Fault Injection Simulator is our managed service for doing chaos engineering. And it then lets you create these chaos engineering experiments that you can then run on your application. And what we're going to do right now is just start off by creating a simple experiment. And we start with creating an experiment template, as it's called. I'm just going to give it a description. Let's call it terminate instances, and then give it a name. Never spell terminate instances. When we create a chaos engineering experiment, the actions is where it's happening. As the name suggests, these are the actions that we then include into our experiment. And an action, well, it can be a lot of different things. I talked about terminating an instance, which is what we're going to do now, the basic experiment. But this could be, we could add latency, we could for instance, use deny list to stop certain traffic. We could fail over RDS instances and so on and so on. So there are a bunch of different types of actions that we can use. So let's call this terminate instance. And then we can select one of the actions we have available. This is going to be against EC2. And let's select the terminate instances one. we're now adding just one action, but one experiment could include multiple actions. So say, for instance, first we're terminating an instance, then we're adding latency, or vice versa. It could be that we're doing both things at once, and so on. So these could be quite complex. And this is usually how a fault within a system looks. You don't have one single thing fail, but instead you have multiple things happening, gradually increasing latency, or adding, you're perhaps having issues reaching one service, and then eventually something else fails, and so on. But let's just do one in this case.
And then while we do that, let me ask the nerd question. This can also be added by infrastructure as code as well?
Yes.
Okay, because I don't like the console, so I'm shocked by looking at it.
No, it's just nice to have a visual view of what we're doing. But yes, you can use infrastructure as code. You can use the CLI if you're a fan of the CLI. So you can create your templates using JSON, YAML, and then simply, then create those in FIS, and you can run the experiments from there. But you can use CloudFormation, you can use Terraform, CDK, whatever you wish, Jonas. So don't you worry.
Then I'm feeling better. And then I still want to get the console, which is not editable forever, right? So I want accounts where you cannot edit anything in the console. That would be a feature request for the console team.
Well, I guess you could restrict through IAM. Yes. All right. So then when we're selecting our targets for this experiment, we can do that simply by selecting a target, or we can use tags, filters, and so on. And by using tags, we can then filter on specific tags that we have for our infrastructure, the ones that are only tagged with FIS ready, things that we want to target, and filter by, for instance, a certain availability zone, and so on. In this case, let me just select one resource just to make it easy. Save. Next step, we need to have an IAM role that allows us to run these experiments. I'm selecting one that I've created before. And this way we can also restrict, in the same way that you talked about with the console, we can restrict, for instance, that I as user, I'm only able to do experiments where there is this specific tag, or only on these types of resources, so on, as a way to make sure that we're safe when we're doing experiments. The next thing is what's called stop conditions. And stop conditions is our safeguard. So let's say that I'm doing an experiment and something actually breaks. Remember, I said before that we're not actually doing this to break things. We're actually doing it to prove that things are reliable or resilient to failure. So then we, of course, need to have safeguards. So I can add multiple CloudWatch alarms. And if one of these alarms sets off, it will then stop the experiment. In this case, we're doing a terminate instance, which is kind of hard to stop because it is just terminating an instance. But say that we have CPU stress, or we're using latency and so on. It will then stop the experiment and roll back to the previous state. All right, I'm adding one, creating my experiment template. And now with that in place, we are good to just start our experiment. So let's just open the EC2 console as well, so we can actually see what's happening.
That's kind of an interesting, powerful feature to being able to react on CloudWatch alarms at the end, right? Because you can then just prohibit, like, completely taking your site down or something like that.
Yeah, and a common question is, should I do chaos engineering in production? And well, that could be the end goal. Of course, you want to start out in testing, you want to start out in staging, or whatever development environment you might have. But an end goal should be, for most, to be able to do it in production as well. And then those safeguards, they become super important, because once again, we don't want to break things. We want to prove that things are reliable.
And is there sorry for follow-up question on FIS? Are there opinionated templates prepared by AWS that users can use?
So we provide, through our AWS samples repository on GitHub, we provide a bunch of different templates that you can use, yes. But since this also so much depends on the type of environment you have, and you often need to then adjust them for your environment. But yes, you can use those as a starting point to be able to then start creating your different experiments. So in this case, we have 3 instances running. We picked one of them. So now let's just simply start our experiment. And since this is actually going to terminate an instance, before we start it, we need to actually confirm, because this is basically like deleting a resource. If it was CPU stress, it would do the CPU stress. It is not a simulation. This is actually happening. So let's start the experiment. And fairly quickly, it moves into a running state, and then it will do all of the actions we added. In this case, we have one action.
What's the latency for those experiments to start? So if I think about this being part of my pipeline, I want to have a pipeline that executes quickly.
Yes.
How fast will this?
So in this case, I don't know how long I talked for, but was it 10 seconds, maybe?
Less?
Yeah. So it starts the experiment pretty much straight away, and then it starts doing the actions. And different actions have different times before it can actually start doing it. But a terminate instance action, that's fairly straight away. So we can see it's already completed.
Mm-hmm.
And if we check the EC2 console, we can see that one instance is now shutting down and being terminated. And this experiment, well, maybe it was, like I talked about before, a way to confirm that our autoscaling groups are working as intended. So as soon as my autoscaling group noticed that one of the instances is being terminated, it should then start spinning up a new one. So that's the most basic of chaos engineering experiments that we did. And this is one of them. But let's say that latency, I mentioned that multiple times, that's sensitive for us. Well, maybe we want to create experiments around that. And those are then experiments that we always want to test. Maybe we're measuring that our API calls in this application needs to be below 50 milliseconds or whatever the target for our application is. Well, maybe that's a way to then test something in our application. We add latency, we add CPU stress and so on to see how does the application behave if we're doing that.
But that means that so when looking at the pipeline, which I hope that we will do as well, we will need to have tests being executed in parallel of the experiment somehow, right?
You mean test as in?
So at the end, if you want to put some pressure on your application,
right,
while the chaos engineering test is running, you need to have a parallel thread, right, where you're doing some verifications. Or what's the?
Yes, well, the way to do that would be through CloudWatch alarms, basically. Mm-hmm. So let's say that we then have a latency goal. We need to be below X amount of latency or response time for API calls. Well, then we can use CloudWatch as a way to measure this through Canarius, for instance, and then we can set up an alarm tied to it. If it goes above this amount of response time, well, then it should trigger an alarm, which would then also abort the experiment in that case. So it's a combination of using CloudWatch as a way to measure things and also set up alarms that we can use as stop conditions. Mm-hmm. It could also be that we're skipping those alarms, we're just measuring, and then we go back to our dashboard, our observability dashboard after the experiment and check if things are staying within those limits that we've mm-hmm. set up, our business metrics, basically.
Cool, thanks.
Yes. All right, so just to wrap up this experiment, we can see that one instance is terminated and a third one is now up and running again. So we verify the behavior of our autoscaling group. Things works as they should. But one of the things we're seeing here then is that it takes me a while to do this. And this is not something that I could do manually or should do manually on each deployment, for instance, because that's just going to eat up my time. So that's why we want to automate it. And there are different ways of automating experiments. We can also schedule them, which is quite common. So maybe once a day or once an hour, we're running certain experiments to test, because things change in an application, not only because I deploy new code, but there might be other teams making changes to the application. So if I haven't done a deployment in the last week, it could still affect my service because team X has done a new deployment, and that's a dependency for me, for instance. So scheduling is one way of doing it. But now, finally,
before we go there, I would want to add one more question, because EC2 is something I did 5 years ago. So how? Sorry for that, but how would you use FIS at the end for testing resiliency of serverless applications, or something that is built on managed services, or do we not need to do that there? Is that something some other experiments?
Of course, and yes. So when we're talking about, for instance, compute, we have EC2 on the one end on the spectrum, and then we have AWS Lambda on the other, and we have containers of different options as well in between. And all of them, they offer different levels of abstraction. And when we talk about this, it's when it comes to resilience, it's a matter of AWS owning certain parts of it, and you as the user or customer, you own other parts of it. And depending on what service you choose, we own more of the resilience of the cloud, while you as a customer, you own resilience in the cloud. So certain things, depending on where you end up on that spectrum with your choice of services, well, certain things you don't need to test, for instance. But certain things you still want to test, because even though we own that part, you might want to test what actually happens to my application if there is this type of issue, for instance. So yes, you can do experiments with EC2, you can do them with containers, and you can do them with AWS Lambda as well. And then a bunch of other managed services. There are many native actions you can use in AWS FIS today, covering, for instance, ECS, EKS, and you can do it on many other services as well. When it comes to AWS Lambda, we don't have any native faults today, but there are different ways you can do it. That's an entirely different session to go into depth on, but you can, for instance, make changes to configuration, you can do throttling, you can use different types of libraries to inject faults into the code. There is, for instance, one called Failure Lambda, very famous library, which is written by me, so I think I can promote it. But there are other ones as well out there.
Yeah, that sounds like a totally different session, and of course not in scope of what I try to do on my channel. So maybe we'll find someone else to host that session, because it sounds interesting for me as a developer.
For sure.
With that, so let's end the bad part of the session, which is looking at the console, right? And let's look at the CI/CD pipeline. I hope that we're going to see some pipeline now. And as time goes by very fast, if you're having fun at this stage of the recording, Gunnar and I decided that we're going to split the session. So please tune back in soon, where we're going to look at the actual implementation of chaos engineering within the continuous deployment pipeline. Thank you so much for watching. Looking forward to see you back soon. Bye-bye.